Good day, everyone. Today we are going to study on tutorial 5. Okay, so let us start with question number 1. Okay, so determine the types of matrices and state the reasons. Okay, so have a look on here. So for question A, the answer is upper triangular matrix. Why this one is known as upper triangular matrix? Because the element below the diagonal here is actually mostly a 0. That's why it's upper triangular matrix. Meanwhile, when you go for diagonal, question B, diagonal matrix like this, you can see the diagonal part here. And then this top part and the bottom part, all of these elements are 0 except those at the leading diagonal. That's why for question B, the diagonal is known as diagonal matrix. Okay, this is the difference between these two questions. Okay, so moving on to next question, question number 2. When we move on to question number 2, the question asks, is it possible to obtain the product? Okay, what is the idea about product? Product is actually mean hasil darab, two things multiplied together of A and B. Okay, so if they ask possible or not, the answer is yes or no. The answer for this question is no. Why? Because based on the column that we found in A, this one is 2 times 2. This one is 3 times 2. Okay, so for the concept of multiplication for matrices, this one, the middle one, have to be the same value, only we can proceed. But this one and this one is not the same, not same value. That's why the number of column A is not equal to the number of row B. Okay, that's why cannot carry out any multiplication. As for question B, is this property of determinant? Okay, so determinant is something that involves square matrix. Can be big square or mini square like this. Okay, we have 4 number here, or we can even have 9 number here like this. Okay, so please take note that normally for determinant, to carry out determinant, normally it's involve square matrices only. This one is not square matrices, okay? This one look like rectangle, okay? So this one will be answer for question number 2. Let us proceed to question number 3. Okay, look at question number 3 here. Okay, question number 3 here is something talk about A matrices for this one and B matrix for this one. So for me, I will strongly suggest that they try to write something where your handwriting try to write bigger, so that when you do this operation, it's more easier and most visible for you. Okay, please take note extra on your sign. Make sure you get the sign correct. As for question A and B, I also highly recommend you write down the matrix first. Only you continue to find the answer. Example, A plus A, you get this answer. B plus B, you get this answer. C plus C, this one. So, okay, so you will get this one, A, and then this one, and so on, okay? And for minus, please take note on this minus sign. And then you have to make sure the sign, you get the correct sign for your answer. As for question involve multiplication and also minus, you do the multiplication first, only you do the minus. So this step focus on multiplication. So each of the number you multiply 2 into it, and then this will multiply into it, and then this stage is start to minus. Okay, then you get this final answer. Okay, please show your step by step like this. As for question 3BA, okay, question E3BA, this one cannot proceed. Why this one is invalid operation? Why? Because the order of A is 2 times 3. The order of B is also 2 times 3. Since this number and this number is not the same, so that's why we cannot proceed for multiplication. Okay? Okay, please take note on this idea. Okay? Okay. So not every time when this thing can be done. Sometimes they need you to know that some operation cannot be carried out. Okay. So let's move on to question number 4. As for question number 4, they ask for looking for the answer C, D, P, Q. As for this one, student is encouraged to do comparison. So this one compare with 9, this one compare with 2, this one compare with this, and this one compare with this. After you compare, you try to list this all out. After you list out, preferable to start from the easier one first, okay? This one, you can use the elimination method that you learn in simultaneous linear equation. You also can use substitution. It's really up to you. So the most important key is to find the first value first. After you find the first value, you can proceed to find the rest of the value by substitute into the equation. Then you find your Q is equal to -3, and then you find your C is equal to 2, and then you start to substitute, and D is equal to 1. Okay, so as long as you find 1, it's way is getting easier for you to look for the rest of it. As for question B, you look into this one. We start from this one is that, okay? We don't start from this one, we start with this one. So this one, you compare and then you get 16. X is equal to 2. As for this one, you compare this one, you just need to write down, okay? Y is equal to 1. Y is equal to 1. So moving on to question 5, let P to this one and Q for this one, okay? So let me explain this one by one. Find the determinant for matrix P. So as this explanation here, you can see expanding along the second row. Okay, why they choose the second row? Because the determinant can be calculated using any row. Can use any row. However, in this case, it's easier to use the row or column with the most number of 0 elements. So in this one, row number 2 have a lot of 0 inside. So the process of finding determinant only involve question 3, okay? Involve 3 part, this part only, okay? Let me share with you how to find determinant for this one. So you can see this one, okay, let me write off this one. Huh? Okay, you can see from here, this one and this one is the one that we look into the second row. When you look into second row, it may also involve this one, second column. So after that, we only take out this number, this 4 number will be involved to become your determinant. Okay, this one will involve become your determinant here, -0. Okay, so you can see from here, okay, this one is plus and minus. So you get this one. How to find determinant? Again, this one and this one multiply minus this one and this one multiply. So you get 75. Okay. Meanwhile, when you do question B, actually it's quite similar to question A. It's just that they have extra algebra at the second column here. Okay, so the answer is 75K. So a common factor of any row or column is a factor of the determinant. So this one is actually try to explain the idea of common factor. Common factor is normally refer to one row only. Okay. So I have students ask me about common factor and scalar. Scalar is different. Scalar is have to multiply into each of the number inside. But as for common factor, only involve any row. Okay, one of the row only. Okay, all right. For determinant case, only for determinant only. Okay, like this the absolute symbol, right? So move on. Question number 6. Okay, question number 6. Finally, I want to share with you when you see this type of question, they ask for evaluate the determinant of the matrix by a call factor expansion along the first row. So now this question is only focused on the first row. Okay, so what we should do is we do our determinant for the first row. So you can see from here 1. If I involve 1, I will get this 5602. Okay. If I involve 2, then I will take 4162. Okay. If I involve 3, okay, 3, I will involve this one. Okay. So this is how I get my determinant column. Okay, so but why we want to do adjoint A? Okay, what we can do with adjoint A, how we link adjoint A and also determinant. Okay, let me share with you some keywords. If you want to find the adjoint A, we have keywords example. Okay, I create one keyword for you. First, you need to find determinant. This one is determinant. Second step is called you find your matrix minor. What is matrix minor? This is matrix minor. Okay, a lot of determinant for each of this one. Example, if you example like this one C1, so your determinant is 5602. You find inside here. Okay, this one is C11. Okay, what if C12, then your determinant is 41 and 62. Okay, but did you notice that there is a sign here? This sign negative, negative, negative. Okay, negative. This is a special sign that you need to take extra note on this one. This is a formula to find matrix minor. Okay, formula to find matrix minor is in the formula already. Okay, so the formula that found in your lecture is plus minus plus minus plus minus, and then is plus minus plus. Okay, you have to refer back to your slide to get better concept of this one. Okay, after you find a determinant, you find your matrix minor, you proceed to find your matrix cofactor. Okay, so the mami macho. Okay, after you find the mami macho, and then you proceed to find your ADMA. What is ADMA? ADMA for me stand for adjoint matrix. So what is adjoint matrix? Is the answer that you found here, you bring forward. So what you're going to do next is you are going to write this one into this form. This one into this form. Okay. And then you continue again. And then you proceed. Okay. This one into this form. And then proceed this one into this form. So this is the method for you to find adjoint A. But what if the question proceed, they give you extra, they said, can you find this one reverse, we call it inverse A. Okay, we have to add on one more step to find adjoint inverse. You need to use the answer that found here, -9. -9, put at the determinant here, okay? And then you copy the answer that found in your adjoint A and copy down here. Conclusion. We want to divide this one into two cases. Cases 1, if the question only asks for adjoint A, you use the mami macho and also find the adjoint matrix. But if the question asks you to look for this one inverse A, you have to find the matrix minor, matrix cofactor. This one is adjoint matrix. Okay, then adjoint matrix, the inverse one. So this one. Okay, so there are two types of questions that you will find. Okay, so these are exam question. Normally is direct question. Then how to apply the mami macho and ADMA in problem solving question? Okay, let's see this question. So you're gonna write all these things into like example A, the answer question A, express the problem in the form of matrix notation from the above information. So you're going to write this into the matrix form, and then XYZ is given by the question, and B is also given by the question, 12, 10, and 16. After that, we are going to use, I emphasize again, the method that we learned just now is called inverse matrix method. Okay, inverse matrix method. So you are going to start as I explained just now. This one find the determinant. This one find mami, the matrix minor. Okay, take note on this symbol, Okay. All right. Then after that, look for your macho matrix cofactor. And then you proceed to find your ATMA, then ATMA inverse. Do you notice that the answer that you found here is 1 is going to substitute into here? But after you substitute into here, 1 over 1 is still 1. So 1 multiply any number still back to itself. Do you notice that? So the answer that found in adjoint A and the inverse adjoint A is actually same. This part is the part that extra. Okay, this is the part that extra, which is finally we use the idea that we used just now and find the each of the value. So how to find this one? So 1, -1 times 12 plus 0 times 10 plus 1 times 16. So you get 4. Again, next one, 4 times 12 plus, okay, and then -1 times 10 plus, and then -2 times 16, okay? Then you get answer 6, okay? Lastly, -2 multiply 12, 1 plus 1 multiply 10 plus 1 multiply 16, they'll get answer 2. So finally, you will get 4, 6, and 2. Okay, so conclusion. Now we summarize into 3 now. If the question asks for only adjoint A, so you just use the mommy macho. The mommy macho, okay, Edma. If the question asks for adjoint A like this, okay, inverse, then you find the mommy macho Edma adjoint matrix inverse. Okay, but if the question is problem solving question, you are going to do the determinant, matrix minor, matrix cofactor, adjoint matrix, adjoint inverse. Then finally, you find your value by put this one and this one together. Remember, huh? Please make sure you put the right one. You find your this one final answer from here with this one. Okay, then you get your answer like this. Okay, so this is how you solve question involving what method we are talking about? Inverse matrix method. Okay, so if you manage to get this one, congratulations. We use the method accordingly. Use the method accordingly, okay? All right, so now finally we get the chance to learn Gauss-Jordan. Okay, Gauss-Jordan method, elimination method. This will be the 2 different method. Okay, this will be the 2 different method. But now, what is the challenge between these 2 method? As in, this one is, let me go through this one again. Okay, this one, okay, is the working step is totally different from the previous one. Okay, let me go through this one step by step. So you can see from here, this one, 3x plus 2y plus 2z is equal to 10. So you extract the number and then become like this matrix and you write like this. Okay, after that, you have to know that Gauss-Jordan favorite number is 1 and 0. You know why? Because at the end and the answer, you need to make it into like this 1, 1, 1, 0, 0, 0 like this. Okay, so Gauss-Jordan method is final answer should have been like this and then equal to certain value. So since the core idea is have to change all the number into 1, okay, let's see step by step. So now let's see in this matrix, we have this one and this one. Since this 1, 1 is here and Gauss-Jordan like to use 1 as the starter, so we put this one 1 here. The whole row you swap. That's why this instruction actually means row number 1 swap with row number 3. Okay, this one actually means row number 1 swap with row number 3. After you swap, so now back to the idea here. Do you notice that this one is already at 1? Okay, now Gauss-Jordan method is actually like this, okay? Just now we have 1 here, but this number and this number and this number, okay? This number that I take here have to change to 0, okay? Have to try to make them become 0. So how to make them become 0? Okay, by looking at this one is quite challenging. So let me go through one by one. This row is called R1. Okay, this row is called R3. Okay, so this one is called diagonal. This one is called diagonal. So in Gauss-Jordan method, they very emphasize to get help from the diagonal here. Okay, what I actually doing is, okay, let you see how I do. I copy, I want to make this one become 0, right? I want to make this one become 0. So I will do like this. This is the row. So R2, okay. Okay, how I see. Okay, I write off and do again. So this one is the diagonal. Okay, I want to make this one become 0. So what should I do? So I am R2, I write down R2, and then the value is 3. And then my nearest diagonal, it cannot be this row because this one is next to it. I have to be either this one only, no other choice. Can cannot get one here, cannot get here, cannot. So we only can get the one that on top only, okay? We only can get the one. Why cannot take 2? Because 2 is very fast, so we only take this one. So R2 is 3, okay? How about my R1? My R1 is 1. Okay, now I try to slow down. So now we cross multiplication. So R2 multiply 1 become 1 R2. And then 3 multiply R1 become 3 R1. What is this? This is the instruction that you found here. Okay, and then now always minus. So again, we start to substitute this number already. So 1, my R2 is 3. 3, my R1 is 1. So 3 minus 3 is equal to 0. Yay! Finally, I managed to convert this one become 0. Okay? I show more example here. I will show more steps here. Okay, next one. This one also using this whole entire row also using the same idea as in this one R2 is 2 minus 3 R1. This one I get from here. I get from here. And then again, I will try to make this one become 0. Let's say it's 2. This one is 2. And then my 3, my R1 is 1. Okay, so 2 minus 3 become -1. Yay, this one become -1. I keep doing. Okay, how about this one? I try again. I use another, this one done already. How about this one, 3? So now my R3 is 3, this one. My nearest diagonal is 1. I cannot use this one. Okay, why I cannot use this one? Because this is the same row. We have to use different rows. So this one is R1. So I write down 1. So now I cross multiplication. Okay, 1 R3 minus 3 R1. So it will become 3, okay, bracket 1, okay, minus 3 R1. So the answer is 3 minus 3 still get 0. So you can get 0 from here. So now I managed to convert this one become 0 again. 0 again. This one just now I convert. So you continue to use this one, apply on here. Okay. After you're done with this one, okay, then you continue to do the same thing over again. Then you will find at the end you get 0 0 0 0 0 like this. What if you don't what if your answer is already all diagonal already, but here still have 1? You also can use example R3 minus R2, that this you can get the R3 minus R2, you get the R2 result. Also can be like this. This one minus this one. Okay, this one minus this one. So you get this answer. Also can be like this. So for Gauss-Jordan, hence Gauss-Jordan method can be a lot variety. Okay, but the core idea is do whatever plus minus just to make sure this one diagonal is 1 and this one down here and upper here becomes 0. So finally, the answer is x equal to 2, y equal to -1, z equal to 3. Okay, so moving on to question 9. Question 9 is also using the system or linear equation. Okay, this one is quite similar to the one that we learned before this. So you find this value. Okay, you write down your equation. You write down your matrix. Okay, you write down in this format. You find the determinant. Okay, you find the value x and y and z. Okay, and then you remember to write down your full working step. Okay, so be careful when you do the determinant. Okay, do it step by step. Okay, can. So now finally we use the Gauss-Jordan elimination method. In this SEM also we are using the SEM. So for this question, do they show any swapping number here? No, they don't. Why? Because the question itself already have one on the top left. All right, they already have, then they continue to proceed. Example, this one is already 0, then we skip. How about this one? So this one is R3 is equal to 6, and then this is the diagonal, and then the R1 is equal to 1, cross multiplication. So it will become 6R1, sorry, it will become 1R3 minus 6R1. Okay, or you want to rewrite it again just like this one also can. So up to you. Then let me put the number into it. So 1 R3 is what? R3 is 6. Okay, all right, and then the 6R1 is 1, so I get this 0. Okay, so here that's why I get this answer as in 0. Okay, so you continue repeat until you get this answer. That why suddenly have -1/2 squared? Why? Because you look at this one, right, this row, right, they are not one, they are not written in one. Hence, how to get rid of this number so that they become 1? So you can multiply by -1/7 so that it become 1. When you multiply, here also can, here also can. Okay, all right, you can try this, and then you can see from here, here is negative. Okay, here is negative. This one you can see the diagonal here. This one is add. We can also this one and this one. Okay, you multiply by 1 over that, you get this answer also. So that's why your final answer you do until you get this part, and then 2, 1, -3. Okay, so I also have students ask me question like example, can you simplify the question first? Okay, some students, they don't want to do in a big number. They want to simplify it. Okay, when you answer question 9A, you need to write like this. But when you proceed to do question B and so on, you are allowed to make the number simplify it so that you operate with a smaller value, also possible. Okay, so you try to go through each of this one over and over again. Okay, I'm sure you can cope the idea of all this. Okay, so that's all for today tutorial. That's all for the tutorial. Thank you everyone. Okay, have a nice day.